Hi everyone, welcome back. This is Online Logic. I'm going to be doing a couple practice problems from 7.4. Erica actually sent me 3 problems that she was having difficulty on from the textbook. And so that's what we're going to be working on. In fact, if you're following along, the problems we're going to be looking at is problems number 29, number 31, and I think number 41. So these are the problems we're going to take a look at in the 10th as well as the 9th edition. Okay, so let's go ahead and sort of go through this problem. The first problem, 29 here, looks like this, where we have um, if G, then J, then if H, then Q. Line 2 here is J and not Q. And the conclusion we're looking for here is not H. Okay? So first thing, of course, I always start by looking at the conclusion here. You can see I have an and not H, which here is my H. You can see here, if I could get not Q, I could use a modus tollens to conclude not H. So that seems like I could, if I could simplify Q to get by itself, I could commutate, simplify here. But the problem is, in order to get this sequence, to use this sequence, I need to unlock it by getting this thing. If if G, then J. You can see here there's sort of difficulty. I've first got to deal with this, and it has something to do with the J here. So it looks like the first thing really I should do is just simplify to get J by itself. So that's going to be line 2, simplification. Right? Now that I have J by itself, the question is, what should I do here? It looks like, what if I added something that had to do with G, right? And you're going to see that actually, well, maybe a work here is actually an implication that comes later down the road. So what I'm going to show you here, and as I go through the problem here, I'll go back and explain why I did this, is I'm going to add not G. I'm going to add not G. And you're going to see why here in just a moment, but that's 3 addition. Right? Now that I've added not G, what I actually going to have to do is, because what I'm trying to do is set up an implication. So that means I need to commutate these two first, right? In fact, well, let me commutate it and then I'll go over what an implication is. So I'm going to commutate it to not G or J. Basically, I'm just switching them around. So that's line 4, commutation. Now, remember here what the rule of implication looks like, right? The rule of implication says that if you have if P then Q, that is logically equivalent to saying, well, you either don't have P or you have Q, right? Now notice here by adding, this is why I added the not G, because now I see I can immediately do, if I do an implication here, what I'm going to end up with is I'm going to end up with G then J. Notice that I was able to get rid of that negation. Look, here I have it. I just got the J. That's exactly what I needed to do my modus ponens here. You can see now I can go through with my original sort of plan that I came up with using the reverse engineering the modus tollens. So let's write down what we just did though. That's line 5, implication. Right? The trick was to realize I needed this in the beginning. And now that I know that I need this, I was able to sort of go back, well, if I added a G, blah, blah, but it had to be a not G to use implication. So let's go through this. Now that I have this, I can get H, then Q, right? That's line 6 and 1, modus ponens, right? And now that I have this, I need to commutate line 2. So line 8 is going to be not Q and J. That's line 2, commutation. Now that I've commutated it, I can simplify to get not Q by itself. Line 8, simplification, right? Which means line 10, now if I don't have this, then I must not have this. That's not H. So that's line 7 and 9, modus tollens, right? Now, in order to remember, so this is the proof of the problem you were looking at here. The reason it was difficult was ultimately you had to see that you had to get this, that you had to add a not G. And the reason I was able to see that is because I realized that I needed this sequence here. So if we reverse engineer it next time, whenever we see a sequence like this, ask yourself, what happens if we do an implication, right? You can see you could do it that way, right? Because if you did an implication of this, you'd get not G or J. Since we had J, we could have figured out how to do it, okay? So that's problem 29. Let's take a look here at problem 31. Which actually I think is, well, I don't know. This one, there's not too many problems that utilize the material equivalent. So I think this one's maybe hard in the sense that we're not used to using the rules. Let me make sure I get this right. I think the third premise here is not P, and the conclusion we're looking for here is not R. Okay, so this says my first premise here is K if and only if R. K, if I can get K by itself, then I can get R, then P, not P. But my conclusion I'm looking for is not R. So let's sort of ask ourselves, by looking at the conclusion, how could we reverse engineer our way back to one of these premises? Well, if I need a not R, right, you can see if I can get this by itself, I could use a modus tollens to get not R, right? So we'll just sort of put this off to the side. Well, I don't have enough. Well, here we can write over here. You can imagine this is our strategy, right? To reverse engineer, right? To get the not R, I could do a modus tollens with lines 3 and an R then P. But in order to get the R then P, right, I have to get K. How can I get K? Well, it looks like I'm not sure how to get it. But you can see here K must have something to do with this first premise. So now, fortunately, because there's only one material equivalence rule that deals with these, that's going to be our obvious first bet on what we're supposed to do here in terms of a material equivalence. So let's do a material equivalence on line 1. Now notice that for material equivalence, here I'll sort of slide this back over, right? For the material equivalence, there's two different forms we have to remember, right? Because we have P if and only if Q. That's logically equivalent to saying if you have P, then you have Q, and if you have Q, then you have P, right? But P if and only if Q can also be logically equivalent to saying, right, I have P and I have Q, or I have not P and not Q, okay? So the question is, which one of these forms do we want to actually utilize here? What we're going to do is, because if we utilize this form, we could get K potentially. We get K, right? If we maybe give us a chance ultimately to get this thing set apart, we could simplify. So I say we use this form right here. So what's line 4 going to be? Right, sorry, I wrote over here a little bit. Line 4 here is going to turn into, right, K and R, or not K and not R. Okay, so that's line 4 equivalence. Okay. Now, okay, so now what we're going to do is, now that we've done the equivalence, the question is, what is the next step to do? Well, let's take a look here. Is there anything we could do with line 2? Now remember, since this is rules of replacement 2, this section, we should ask ourselves what rule of replacement looks like, has a framework that has 3 different variables and uses conditionals, right? And the answer is that's exportation. So let's do an exportation, because if you ever see that you have a substitution instance, just do it. Because what you're going to end up with here is K and R, then P, right? And that's line 2, exportation, okay? Now that if I don't have this, what does that mean? It means line 6. You can see here the problem's starting to work out, because if you don't have P, right, then you must not have K and R, right? Which means that you have, that's lines 5 and 3, modus tollens, right? Now that if I don't have this, then you can see disjunctive syllogism, I must have this thing here. So that's going to be not K and not R, right? So that's lines 4 and 6, disjunctive syllogism. Again, with the disjunctive syllogism, what we have here, right, is that since we don't have this, right, we must conclude that we have this thing here. Okay? Now, well, I meant this thing. I underlined the wrong thing. Sorry about that. We'll move the line over here. Okay, so now that I have this, you can see what can I do here? Well, let's see here. Now that I've done the disjunctive syllogism, my goal is to get not R by itself. I still need to get this thing by itself. You can see I can simplify to get not K right now. But remember, not K doesn't help me do a modus ponens, and you can't do a modus tollens with that. So what do we need to do, actually? Well, wait a second here. We have not R right here. What am I thinking? So that's going to be not R and not K, right? Line 7 commutation. And now I'm just going to simplify to get not r. I sort of didn't see it for a second there. Okay, so that's line 8 simplification. And there's the answer. Okay, so that's the proof. Okay, so let's do the next problem here, which I think you were saying, Erica, that this is the most difficult problem, or that you were really struggling on this problem. So let's do problem 41. And you're going to see here that in this problem, we really are going to have to look at using lots of implications, actually. So we have S or T, then S, then not T. Line 2 is going to be S, then not T, then T, then K, right? And then line 3 here is you have S or T, and thus you can conclude you have S or K, right? So the question is, what are we going to do with this problem, right? This problem looks fairly crazy when we first look at it, but let's think about it for a moment. If I have S or T, right, this first line says if you have S or T, then you can get S, then not T. I do have S or T. So the first thing you should do here is a modus ponens, because this is a substitution instance for this, which means I can unlock this level, if you will. So that's going to be S, then not T, right? Lines 1 and 3, modus ponens. Right, you can see S, then not T. Well, that's this substitution instance. So line 5 here is going to be this, T, then K. And that's lines 4 and 2, modus ponens, right? Now that I've done those two modus ponens, the next question is, what can I do now? And this is where it gets a little difficult, because you're going to see that what we have to do is actually, in order to set up our implication, and here let me remind you what the implication rule is. Notice I guess I didn't start with the conclusion here, I just jumped right into it. Right, you can see here, if what's the rule of implication? Let me write it up here for you. Again, it's if you have if P then Q, that's logically equivalent to saying you have not P or Q, right? So you can see here, maybe I could do an implication here and get it to look like this, where it would end up being not S, then T. You can see, though, that there's a problem here, because if I do that, I'm not in a good position ultimately to get either S by itself or to get an implication that says not S, then K. Because remember, if we reverse engineered this problem, right, S then K, S or K, this is logically equivalent to not S or K, which means that if you did an implication here, you get not S then K, right? So if I can get this thing somehow, I'll be in a good condition. You can see there's a K here. If I do an implication on this T, then I'm going to end up with a hypothetical syllogism, right? Because it'll be not S then T, this sort of thing. But you can see here, in order to get this negation in front of the conditional, I'm going to have to do something else. And what I'm going to need to do is I need to do a double negation on this. So line 4 here is going to be not S. I'm going to do a double negation on the not S or T. That's line 3, double negation. And I think this is the reason you're having trouble with this problem, is to see to do the double negation. Okay. Now that I have the double negation, let's do the implication. Now remember, if you do the implication, that means that this thing is going to turn into just S, right? And this is going to turn into a conditional. And then this is going to turn into a T. But you can see what's going to happen with my extra negation. It's going to carry down. So I get not S, then T. That's what close to what I needed here, right? Because now that I have this T, notice with line 5 here, I can create a hypothetical syllogism. So line 6 ends up not S, then K, right? Oh, I forgot to write my reasons here. So double negation, line 5 here was line 4 implication. This is lines 5, whoops, 4, 5, 6, 7. Sorry about that. I bet a lot of you watching this video caught that I'm completely numbering this wrong. Look, 4, 6, 7, 8. Sorry about that. Okay. So now that we've done this, that's line 5 and 7, hypothetical syllogism. Okay, number 9 here. Now that we've done this, let's do an implication. What do you end up with an implication? You end up with this. It's got to be S or K. Wait, did I skip a step? Let me make sure I got it right. Actually, technically, you'd end up with a not S or K, right? And then line 10, so that'd be line 8, implication. And then because you did this not, I tend to do this in my head quickly. Whenever I see a double negation, I just automatically realize that that's just going to cancel out. So that's line 9, double negation. Okay, so these are the 4 problems you were asking about. So hopefully that explains it for you. Okay, thanks a lot, Erica.